The growing global fascination with the mysterious interstellar object known as 3I/Atlas has intensified as new reports circulate about NASA's Planetary Defense Group allegedly initiating targeted observations after astronomers detected strange alloy emissions and other behaviors that defy known cometary physics. This object, believed to have originated from beyond our solar system, has drawn unparalleled scientific scrutiny because of its unusual characteristics and the possibility, however remote, that it may contain some form of alien technology. Such speculation gained traction when the International Asteroid Warning Network, a major NASA-supported coalition composed of observatories, space agencies, and research institutions around the world, officially added 3I/Atlas to its list of objects of significant interest and potential concern. The inclusion itself does not imply danger, but it highlights the scientific community's recognition that this object behaves differently from ordinary comets or asteroids typically monitored by planetary defense teams. The IAWN's decision came shortly after observers reported that 3I/Atlas emitted a type of metallic alloy not commonly found in natural celestial bodies. While many experts caution that the alloy could be the result of unknown chemical interactions occurring as the object nears the Sun, others argue that the composition is anomalous enough to warrant deeper investigation. This element, paired with its sharp changes in brightness and its non-gravitational movements, has fueled speculation that the object could be more technologically complex than previously assumed. Unusual shifts in its trajectory, the shape and direction of its anti-tail, and the density distribution of its coma have further challenged existing models of comet behavior. In response to this escalating curiosity and concern, the International Asteroid Warning Network launched a dedicated campaign that begins in late November and runs through January 27, 2026. This extended observational effort aims to gather highly accurate astrometric measurements, precise data about the object's position and movement, to determine whether its unpredictable behavior can be explained by natural phenomena such as sublimation jets, radiation pressure, or dust morphology. According to the official circular released by the Minor Planet Center on October 21st, the central goal of the campaign is to refine methods for measuring comets that possess complicated or extended structures, especially those with comae and tails capable of distorting the apparent center of brightness. These distortions frequently lead to errors in calculating the true trajectory, making it difficult to reliably predict future motion. The Minor Planet Center's notice emphasized the importance of training the global observing community to properly extract accurate astrometric data from comets with unusual morphologies. It explained that standard techniques often fail to account for the subtle displacement caused by asymmetrical dust emissions or extended features that obscure the nucleus. For this reason, IAWN is hosting a preparatory workshop in early November to teach observers how to adjust their imaging, processing, and measurement strategies. Only participants who attend this workshop are permitted to join the official observational campaign, ensuring that all contributors apply consistent and scientifically rigorous methods. This large-scale collaboration represents a rare moment in which astronomers worldwide unite to observe a single celestial object, driven by its peculiar structure and the global implications of understanding its true nature. The decision to focus on 3I/Atlas has been further justified by the scientific intrigue surrounding its discovery earlier this year. Since the moment it became visible in July, the object has baffled astronomers because of its size, roughly comparable to Manhattan, and its highly reflective metallic-like sheen. While interstellar visitors, such as 1I/Oumuamua and 2I/Borisov, have been observed before, 3I/Atlas appears to combine features of both known interstellar objects: the cigar-like or flattened shape suspected in Oumuamua, and the clearly cometary characteristics visible in Borisov. Yet unlike those earlier visitors, 3I/Atlas has been reported to behave in ways that cannot be easily reconciled with known physics, including abrupt changes in spin rate and suspected outgassing that does not match typical comet chemistry. Scientists are especially intrigued by its anti-tail, a rare optical phenomenon in which particles appear to project forward toward the Sun instead of trailing behind the comet as expected. This effect can occur naturally under certain viewing angles. But in the case of 3I/Atlas, the direction, shape, and density of the anti-tail defy traditional interpretations. For some astronomers, this unusual formation could point to unknown dust dynamics, influenced by interstellar material not commonly found in our solar system. For others, the unusual orientation of the anti-tail raises questions about whether artificial forces could be at play, although the mainstream scientific community remains cautious about such interpretations. Despite the extraordinary theories circulating online, most experts emphasize that the current campaign does not assume any threat of impact. Instead, it reflects the importance of accurately tracking any interstellar object that enters Earth's neighborhood. Because these objects originate from outside our solar system, they often carry chemical signatures, dust structures, and orbital mechanics that differ from everything studied previously. Understanding them could reveal new insights into the evolution of planetary systems, the composition of distant cosmic environments, and the potential for life-bearing materials to travel between stars. However, the presence of strange alloy emissions has undeniably motivated closer examination, as such a feature could either be an extraordinary natural discovery or evidence of something far more complex. By initiating this campaign, IWN aims to gather the most comprehensive data set ever assembled for an interstellar comet. This includes detailed measurements of its nucleus size, mass distribution, gas emissions, dust production rate, reflectivity, and rotational behavior. Observers across the world, ranging from space agencies to university telescopes to advanced amateur astronomers, will contribute their findings to a central system that analyzes the object's movement with increasing precision. The campaign may also include spectroscopic analysis to decode the chemical composition of the unusual alloy-like emissions. This data is invaluable not just for determining whether the object poses any realistic danger to Earth, but for advancing our understanding of interstellar materials and processes. Astronomers also hope that the extended monitoring period will capture any shifts in the comet's tail structure, potential fragmentation events, or sudden surges in outgassing. These behaviors can provide essential clues about the internal structure of the object. For instance, if its nucleus contains pressurized pockets of frozen gases, solar heating could cause explosive releases that alter its trajectory unpredictably. If its metallic emissions continue or change in nature, this could confirm whether they arise from natural interactions or something synthetic. Every piece of information will help determine whether 3I/Atlas is a typical interstellar body or a truly unprecedented object entering the solar system. The excitement surrounding this event has transcended scientific circles, sparking widespread public interest. Social media platforms, science forums, and news outlets have circulated theories ranging from the grounded to the speculative, with many wondering whether the object could be an alien probe, a derelict spacecraft, or a fragment of advanced interstellar debris. While such ideas remain unlikely, they have undeniably fueled global curiosity. NASA and other space agencies continue to emphasize that there is no confirmed evidence of extraterrestrial technology, urging the public to await verified results from the observational campaign. Ultimately, 3I/Atlas represents a rare and extraordinary opportunity for humanity to study an object formed in a distant star system, shaped by environments completely foreign to our own. Whether its strange behavior proves to be natural or something more unusual, the data collected over the next year will expand our understanding of the universe and our place within it. The scientific community is unified in its commitment to uncovering the truth behind this mysterious visitor, determined to observe it with unprecedented precision as it continues its silent journey past the sun and across the vast expanse of space.